Hi everyone, I am Madam Rosmaya. I'm a Form 6 teacher at SMJK Yuhua Kajang. So, what are we going to discuss for today's video? So, we are going to discuss about this question. So, the question here actually is the question that we missed last week. Okay, a question on the free online tuition that given to you all already in the worksheet. Okay? So I will give again the worksheet in below the description in this video. So let us read the question first. So a moving lorry is accelerating on a highway with a constant acceleration A. So inside the lorry, a small bob with mass M is suspended from the ceiling by a light string. So if the pendulum makes a constant angle 30 degrees with the vertical, so what is the magnitude of A? So by just knowing the angle theta 30 degrees, we can calculate acceleration of the lorry. So how can this be done? Okay, now let us continue. So, first step, we determine the direction of the motion of the lorry. So, the direction of the lorry is to the left. Okay, label with A, acceleration to the right. Okay, to the right, not to the left. Because the bob direction is to the left. Another force is the force of the lorry from the engine thrust of the lorry, so to the right also. And another force is tension in the string, okay, and then the weight of the bob, which is equals to mg. Okay, now we draw the vector diagram after we determine all the forces. So all these three forces will make a triangle, okay, complete triangle. So we draw mg. So you can draw tension first. So tension is angle, make angle theta with the vertical. So we draw like this. Okay, tension. Follow the direction this way, and then mg downward. So the force is to the right. So it makes a complete triangle. Why? Because the bob here. The bob here is actually made angle constant at 30 degrees. Okay, so the angle made by the bob here to the vertical made constant magnitude at 30 degrees. So therefore, the shape is like this. Okay, then we can solve theta, okay, by using trigonometric ratio. So we can use tangent theta equals to opposite f per mg. Okay, so now f equals to ma because the lorry moved to the right. So f equals to ma. So we get this from the Newton's second law. And we can cancel out m. Okay, then we substitute the values of theta 30 degrees and the g 9.81. So finally we can get the A, acceleration of the lorry, which is equals to 5.7 meter per second per second. There we got already the acceleration of the lorry by just knowing the angle, the inclined angle made by this simple pendulum. So physics is beautiful, right? Okay, this is the next question. We read first the question. So two blocks connected by a string that passes over a small frictionless pulley. Each block slides freely with negligible friction. so no frictional force involved here. Calculate the acceleration of the blocks and the tension in the string. Okay, so now compare the two masses. Okay, 10 kilogram, here is 15 kilogram. So that means the direction of motion is this way, because this one heavier, right? The mass is larger, 15 kilogram. So it moves this way. And the other object, this 10 kilogram object, move upward. Okay, after determine the direction of the motion, next we resolve the component for the weight of the object. For the 15 kilogram, the weight is downward, M1G. M1 is 15 kilogram. So we resolve the component. Vertical component is okay, the angle here 52 degrees. So the angle here also is 52 degrees. So we use the similar triangle rules. Now we can resolve the component of M1G here. So we have M1G cos theta and M1G sin theta, vertical component and horizontal component, by referring to this vertical plane. Okay, so the horizontal plane is the inclined plane. Okay, so we move this on the horizontal plane here of the inclined plane, this side, at this side. So we do the same now for the 10 kilogram mass. Okay, we choose vertical plane perpendicular to the horizontal plane that we choose at incline at another side of the plane here, 35 degrees. Okay, then the weight is M2G downward. So we resolve the component. Angle 35 degrees, here also 35 degrees. So the component will be M2G sin theta, and another one is M2G cos theta. Okay, so we resolve the component of M2G. So we bring this on the plane here so that we can see clearly the forces that act on the object that made the two objects move this way. Okay, so now by another force that act on the object is the tension in the string. So for object 15 kilogram, the string here, tension direction is upward. For the 10 kilogram mass, the tension is directed upward on the other side of the plane. Okay, so the object doesn't fly or doesn't collapse. So that means this M1G sin theta 1 is and the T here will make the object move in the horizontal along the inclined plane here, horizontally along the inclined plane here. Okay, so by referring to this object, M1G sin theta 1 will be positive because it's the same direction as A, and then the T is opposite direction of A, so we put minus opposite direction, and equals to MA. So M is the mass of this object, M1, which is 15 kilogram, and A, acceleration. So for the other object, so we do the same. Acceleration is upward, so T will be positive. Okay, then minus M2G sin theta 2 equals to M2A. So M2 is the 10 kilogram and theta is this angle, 35 degrees. Okay, so now we substitute the values into these two equations. So M1 is 15, G is 9.81, then the angle is 52 degrees minus T equals to 15A. So for equation 2, okay, we simplify, we get this equation, and then the second one, 10 kilogram, G 9.81 and sine 35 degrees equals to the mass of the second object is 10A. Okay, so we simplify, we get T equals to 56.27 plus 10A. Okay, next we solve using simultaneous equation. So we equate these two because tension comes from the same string. So we can equate these two equations. Okay, then we solve for A. So 10 plus 15a minus 15a to bring to the left side become plus 15a. So we get 25a equals to 59.69, and we get acceleration equals to 2.4 meter per second per second. And to get t, we substitute on into either equation 1 or equation 2. So let's say we choose equation 2, and we substitute a into the equation. Okay, so before you got the final answer, don't round off too early. So we can substitute larger than two significant figures. So we solve for t, so we get 80 Newton. So you remember to round off according to the smallest number of significant figures from the information given in the question. Okay, so done for question 10. We got the answer already. Okay, so next we are going to discuss on question 11. So we read the question first. A rocket stands vertically on its launching pad. The total mass of the rocket and its fuel before launch is 2.5 times 10 to the power of 3 kilogram. So on ignition, gas is ejected from the rocket at a speed of 2.7 times 10 to the power of 3 meter per second relative to the rocket, and fuel is consumed at 7.5 kilogram per second. So find the thrust of the rocket and explain why there is an interval between ignition and lift-off. Okay, so you can see here where the rocket take there is an interval, time interval between ignition before the rocket is lifted off. Okay, so first step, we determine the direction of the rocket. It is before launch. So before launch, the rocket haven't moved up yet. So the forces act on the rocket is the force upward by the engine, by the thrust of the rocket, and another force is weight of the rocket. So we find F first. So from Newton's second law, F equals to rate of change of momentum. So d mv by dt. So we solve for this one, we get v dm by dt. And another one which is plus m dv by dt. So the v is constant, so it is equals to 0. So this is v given 2.8 times 10 to the power of 3 meter per second. So we just use F equals to v dm by dt. Okay, now we substitute the values here, 2.8 times 10 to the power of 3, and then the rate of change of mass 8.2 kilogram per second. Okay, then we get the force 22,960 Newton. So this is the thrust by the rocket. Okay, comes from the rate of the burn rate actually, we give the thrust of the rocket plus the times the speed of the rocket. Okay, now we calculate the weight. So weight equals to mg. So the weight of the rocket with the fuel is 2.4 times 10 to the power of 3 kilogram. So times the g. So this is before before the burn rate of the fuel. Okay, dm by dt. So this is at initial, before the rocket is launched. Okay, we get 23,544 Newton. Okay, now compare these two values. The weight is larger than the thrust of the rocket. So that's why it takes time for the rocket to lift off. Okay, so they are not balanced. The weight is greater than the thrust, so the rocket does not lift off immediately from the launching pad. Okay, so after some time, when the burn rate occur, or the ejection of the gas from the rocket results in the total weight of the rocket continues to decrease, because of the consumption of the fuel. So when the total weight of the rocket less than the thrust, the rocket then managed to lift off. Okay, so hence there is an interval between ignition and lift off. Okay, so done for question 11. Okay, we go next to question 12. Okay, the figure below shows a 65 kilogram man standing on a bathroom scale in an elevator. So calculate the scale reading. If the elevator accelerates upward at a rate of 1.2 meter per second, and if the elevator moves up at a constant speed at 1 meter per second. Okay, so the acceleration is upward. Okay, then another force act on the object is the man is the weight mg, and the reaction force will give the reading for the scale the scale reading. Okay, comes from the reaction force by the weight of the man. Okay, so if the elevator accelerates upward at a rate 1.2 meter per second, so for Newton's law, F equals to ma, so this A is 1.2 meter per second. So the resultant force act on the man is R minus mg. R is positive because it's the same direction as the acceleration. So R is positive and the mg is negative. So minus mg. Okay, so this is the resultant force that make the lift accelerate upward with this 1.2 meter per second. Okay, so now we substitute all these values into here. So mass of the man is 65, G is 9.81. Again, mass of the man 65 and acceleration is 1.20. So the reaction force is equals to 716 Newton. So the reading scale is not this one because this is force. So the reading scale is in kilogram. So we convert this to kilogram. So we divided by the G, 9.81. So we get the mass of the man, which is actually the reading by the scale, bathroom scale here. So which is 73 kilogram. So the reading give a larger value than the mass of the man. The mass of the man is 65 kilogram because it's accelerate upward. So the scale reading shows a larger value, which is 73 kilogram. Okay, now we go to the next question. If the elevator move upward at constant speed of 1 meter per second. So again, we use Newton's second law, F equals to ma. Okay, this time the acceleration is 0. Okay, so R minus mg equals to 0. So that's mean the R is equals to mg. So we bring to the right side, we get the reading in Newton is 638 Newton. So this is the reaction force. But the scale reading will show the same reading as the mass of the man, which is 65 kilogram because acceleration is 0. Okay, so that's all for the question. Okay, that's all for the video and thank you for watching. Don't forget to like, subscribe and comment this video. Bye.